If the world of chemistry were easy and perfect, all of the reactions would behave exactly as you predict. In reality, reactions do not always go to completion for a number of kinetic and thermodynamic reasons. To calculate the percent yield, or the percentage of the reactants that actually turn into products, we need a few more specific definitions on hand. The first new definition of something old is the theoretical yield. That's the maximum amount of product that is possible if the reaction goes to completion. You can calculate this by using regular stoichiometry like all of our previous problems. Next is the actual yield. This is exactly what it sounds like. It's the amount of product that you actually produce. This number is always smaller than the theoretical yield. It wouldn't make any sense to be able to make, like 130% of something. That's physically impossible to create more matter than you started with. The last definition is the percent yield. This is equal to the amount of actual yield divided by the theoretical yield times 100%. It's important to note that these numbers are calculated with mass and not with moles. Next, let's consider a chemical reaction that does not go to completion. Let's say that you start with 25 grams of this cyclohexane and that it reacts completely with excess oxygen. Our problem tells us that we're only going to collect 33.5 grams of this product, and it's asking us to find the percent yield. Our first step is to calculate the theoretical yield, like we would in simple stoichiometry problems. So what I'll do is I'll take my 25 grams of the cyclohexane, convert it into moles using its molar mass, check out the mole to mole ratio in between my starting reactant and my product. It looks like they have a 1-to-1 ratio, but for good measure, I'm just going to write out all of the ratios. That way in the future I don't get into the habit of forgetting my ratios. And lastly, I'm going to convert into moles of my desired product by multiplying by the molar mass of that massive thing. And then I'll write down my theoretical yield after I multiply across the top of my dimensional analysis setup and divide by each thing on the bottom. That means that my theoretical yield is 43.4 grams of this stuff. Excellent. Okay, now to answer the real question, which is the percent yield, what I need to do is divide the actual yield, which is 33.5 grams of product, divided by the theoretical yield, which I calculated is 43.4 grams, and then multiply times 100%. You'll notice that my grams units cancel out, and then I'm left with a percentage unit. This particular one will end up being 77.2%. and that's how you calculate percent yield. Just like any other stoichiometry problem, it's important to practice many of these so you get used to the language in the examples.